Welcome to your first lecture segment in AP Physics 2. This lecture segment is about circuits and electricity. The objectives of this lecture segment are to define electric current, identify the electric symbols for basic circuit elements, use a multimeter to test continuity, identify and construct open, closed, and short circuits. For this lecture segment, the pre-assessment questions are the following. For number 1, which statement below is a correct definition of electric current? Electric current is A, the energy of moving electrical charges, B, the flow of electric charges through a wire or circuit, C, the number of electrons in a circuit element, or D, the attraction between charged particles in a wire. Go ahead and pause the video and record your answer in your notebook. Pre-assessment question number 2. Label each of these electrical symbols with the name of the electrical component it represents. Here are the words that you need to use: battery, resistor, lamp, switch, or wire. Go ahead and draw these symbols in your notebook and label them. Pause the video if you need more time. Number 3. Use a multimeter to test continuity. How do these holes connect to each other? Draw lines to show which holes are connected to each other. Reproduce this drawing in your notebook and draw the lines to show which holes are connected to each other. Pause the video at this time. Number 4. Identify the following circuits. Which is a closed circuit? Which is an open circuit? And which is a short circuit? Draw the circuits in your notebook and label them at this time. Pause the video if you need more time. Number 5. Yuri connected his power supply to a circuit using the red plug. The lamp did not light. What did he do wrong? Pause the video and answer this question in your notebook now. Here are the physics terms for this lecture segment: electric current, ampere, electric circuit, open circuit, closed circuit, short circuit. Legend has it that Benjamin Franklin flew his metal key on his kite in a lightning storm. Do you think the story is true? Why or why not? There is actually some evidence that he actually did perform this experiment with his son. He actually used hemp cord that was tied to the metal key, which is then attached to a Leyden jar. It turns out that the other end was attached to a silk string, which was held inside by his son as he flew the kite. It did not get hit by lightning, but he did see that the strands of the hemp cord were actually repelling one another. If it had been struck with lightning, he most certainly would have been killed. Electricity is the flow of electric charges, typically through wires, actually around wires, conductors, and electrical devices. Sometimes we can see the effects of electricity in nature, such as lightning. Many household appliances and personal devices use electricity. The room you're in right now is probably full of devices that use electricity. Electric current is the flow of charged particles, usually through wires and circuits. Current is measured in amperes, also called amps. Just like water flows through a pipe, charges move through the wire. So how do we measure electric current? Hopefully you remember from last year we used an ammeter. So electric current is measured using an ammeter, or more commonly a digital multimeter. We actually use the Lab Pro equipment, and we use the Vernier ammeter. In order to properly measure current, all the current must flow into the meter and back out again into the circuit being tested. This means that the ammeter has to be wired in series with the circuit. An electric circuit is a conducting path through which electric current can flow. The symbol for electric current is a capital I. Notice that in this picture we're using conventional current. The current leaves the positive terminal of the battery and comes around and goes into the negative terminal of the battery. Electric current I must be the same at all points in a simple single loop circuit. Charge can never be created or destroyed. All the charge that flows through one point in the circuit must flow through the next point also. An open circuit does not have a complete path, so no current flows. A closed circuit has a complete path, allowing current to flow. Here are the electrical symbols in circuits and their physical equivalents. So here you see a wire. For a switch, you can see what a real switch looks like. There they show you a battery. I think all of us know what a battery looks like. A lamp. The ones they show you here in the picture are actually an LED lamp, but it can also be a light bulb. And there you can see a resistor. And sometimes you'll actually get block resistors, which are actually made for classrooms. A knife blade switch uses a mechanical lever to open and close a circuit connection. The handle is an insulator, so you won't get a shock when you touch it. When attaching a knife blade switch to a circuit, do so with it in the open position. A short circuit occurs when electric current follows the path of the lowest resistance. If this switch is closed, then it will cause a short circuit. Can you see why? Hopefully what you see is that when you close that switch, the least amount of resistance is through that wire. So the current is not going to flow through the light bulb or the other resistors. It's going to go directly through that wire because it has the least amount of resistance. So what is a breadboard? A circuit breadboard is a device used for mounting and prototyping electric circuits. Power and ground are connected from an external source to the strips on the edge of the breadboard. So here you can see the red are all connected together. That's the power bus strip. The blue line, which goes straight down both sides, is called the ground bus strip. So you connect the power or red to the red wire from your power supply to the red, and the ground would be your black wire. If the equipment is available, you're going to do Investigation 17A tomorrow in class. It is building an electric circuit using the circuit breadboard. For Part A, you're going to explore the connections on the breadboard. Using the continuity setting on a multimeter, you're going to test whether the probes are connected to each other. In Part 2, identify 3 kinds of connections, power being red, ground being blue, and terminal being black. For number 3, you're going to draw a diagram showing the connections between the holes in the breadboard. Once you do that, answer the following questions. Where should you connect the positive and negative terminals of a battery? Where should you connect other circuit components such as lamps and resistors? How are the holes in the circuit board connected to each other? Draw a diagram showing the connections between the holes in the breadboard on your student assignment sheet, which you will get tomorrow. In Part 2, you're going to wire a simple circuit. Connect the power and ground from a 3-volt voltage source, which is equivalent to 2D cell batteries, to the breadboard. One lead connects to the breadboard's power strip, the other to the ground strip. Connect a simple circuit with one lamp. Does the lamp illuminate? If not, check all of your connections. The 2 ends of the lamp must be in different rows. You can use any rows. This example uses rows 9 and 10. Now you're going to create a simple switch. How can you use wires to create a switch? Does your lamp go on and off as you disconnect the switch? How can you use a wire to modify your circuit to create a short circuit? This doesn't mean actually do it. You're going to answer the question. Here's a hint. Use a wire to bypass the lamp. What should happen to the lamp if you create the short circuit correctly? So here are our assessment questions. Which statement below is a correct definition of electric current? Electric current is A, the energy of moving electrical charges, B, the flow of electrical charges through a wire or circuit, C, the number of electrons in a circuit element, D, the attraction between charged particles in a wire. The correct answer is B. Label each of these electrical symbols with the name of the electrical component it represents. Go ahead and pause the video and do this now. Okay, so let's check your answers. The first one is a wire, next is a switch, then a battery, then a lamp, then a resistor. Use a multimeter to test continuity. How do these holes connect to each other? Draw lines to show which holes are connected to each other. Go ahead and pause the video and do that now. Here you can see which holes are connected to one another. Identify the following circuits. Which one is a closed circuit, which one is an open circuit, and which one is a short circuit. Go ahead and copy these into your notebook and label them. You know what to do if you need more time. Okay, as you can see, the first one is a short circuit, the next one is an open circuit, the last one is a closed circuit. Yuri connected his power supply to his circuit using the red plug. The lamp did not light. What did he do wrong? Pause the video and answer this question in your notebook. When using a power supply or a voltage source, you must connect both the positive or red plug and the negative plug, which is the black plug. If you have any questions about this video segment, please make sure you record them in your notebook and you talk to me next class.